kind of address here is that very first statement. Measurement systems are an arbitrary human invention. So when we look at a foot, how do we know what a foot is? And don't tell me because it has toes. Okay. Why do you know it's 12 inches? Why is it not 10 inches? That's what we said. We defined that measurement system. What does that mean about converting between our measurement systems? 12 inches is exactly 1 foot, which means those numbers have how many sig figs? An infinite amount of sig figs. So when you're converting within a unit system, the significant figures in that conversion are infinite. Okay. The exception becomes what happens when you transfer between systems, say between English systems and metric systems. Well, now you have two different systems communicating with each other. Those significant digits do become an issue because they aren't exact measurements anymore. They're converting between those systems. So we have to remember that when we're thinking about our sig figs. Okay? The next big part that's going to become relevant is thinking about what units we're looking at within our metric system. Okay? And there are what are known as base units and core units. And I quite frankly can't remember which one is which, but one is very proper and one is not, and you didn't bring any for me. So you automatically fail. When we look at length, our base unit, or what I'm going to call, I think I need to call it a core unit because the base unit is the accepted unit for that measurement. When we look at length, the accepted unit is meters. When we look at volume, the accepted unit is liters. When we look at time, our accepted unit is seconds. Well, those are all the same. What is our base unit for mass?
It's actually kilograms.
It's actually kilograms. Okay. I don't like using that as our base unit. Okay. That's our definition of what base is. It's what we base everything off of. So what I'm going to refer to these as is our core units. Okay. We will modify the core units later on. Okay. But when we talk about a core unit, the core unit for length will always be meters. The core unit for mass will always be grams. Okay. These are our, I don't want to use the word basic, but our simplest form of our unit. We can then modify those units using prefixes, just like we did in nomenclature. Okay? So, how can we adjust things to really big and really small? Well, we saw a table like this on, what is today?
Thursday.
So we saw a table like this on Tuesday, where it was just the powers of 10. What is extra about this table? We're referencing prefixes. Those prefixes mean a power of 10. So if I use the prefix capital T, okay, in front of a lowercase m, I'm now referring to terameters. Well, how much is a terameter? Well, how much is tera? 10 to the 12th. So 1 terameter is 1 times 10 to the 12th meters. The prefix means those powers of 10. Okay. How many of you have the powers of 10 and their prefixes memorized already? Probably not. Okay. You might have a couple of them memorized. Okay. And that's fine. That's good. You will need to have some of these memorized. But the question becomes, which ones should you memorize? Okay. Officially, you're responsible for converting all of these, which means that would kind of suggest that we should memorize all of them. Okay, so we'll back off of that a little bit. We'll say there's 3 that you absolutely need to memorize. kilo, centi, and milli. Why those three? Yeah, those are the most commonly used. When you're moving through a chem class, you are very likely to find those prefixes showing up in your calculations. Okay? If you have to spend the time to look up what that prefix means, you're slowing down your solve time. It'll take longer to get through the exam. You likely won't make it all the way through. If you've got those memorized, you will hopefully be able to process much quicker. You can get done faster and more efficiently. What happens if on a test I ask you about pico? Well, that's not one you are expected to memorize. Don't flip your lid. What should you do? Look at the front page of the exam, and the front page of the exam will likely tell you that pico means 10 to the negative 12th. What did you say? I sure hope that didn't get recorded. Okay. Pico means 10 to the negative 12th. Okay? Just got freaking DeGaio going through my head.
Because I didn't bring you any food.
Yeah, that's what it is. Okay. So if they're non-standard prefixes, I will provide those to you on the semester exams. The final exam is another story, and we can talk about that later. Okay? So let's take a look at dealing with these prefixes and how we can convert these across. Okay? So every time we look at a number now, we must include a unit. So I've given a whole bunch of numbers with a whole bunch of different units associated with them. What we want to go through and do is, as our first step, convert that number into scientific notation. Why scientific notation? What does scientific notation use?
Powers of 10.
Powers of 10. Why do I want powers of 10? That is my prefix that I can put in front of the unit. Okay, so let's take a look at that first one. 1200. Just to be irritating, how many sig figs in that number? 2. How do we know that? There's no decimal point. Without the decimal point, the zeros must have a significant figure to the left and to the right. They only have them to the left, so the zeros are not significant. So my scientific notation becomes 1.2 times 10 to the, should it be a positive or negative value? Okay, why do I want it to be a positive value? 1200 is big or small? Big, so it needs to be positive. That's what you look at. Ignore the left, right, because then your frame of reference, depending on which way you're shifting the decimal, can mess with you. Okay. In my book, that's how I would work it. So 1200 is big, so I need to have a positive value. How far did my decimal point shift? 1, 2, 3 places. I have 1.2 times 10 to the third. What's wrong with that? There's no unit. Always include the unit. How do we then convert this to our new number? Well, our new number is going to be 1.2. And now I have my new unit. 10 to the third was kilo, which was a lowercase k, meters. That's how I get to my new unit. Go through and do those last 3, or those next 3, and if you got questions, raise your hand. All of these are 1.2s, all the way down. That was super original and exciting. Way to go, Mike. We then need to multiply by our power of 10. Okay. Is 0.012 larger or smaller? Or a large number or a small number? Small number, which means my power of 10 needs to be negative. How far did I shift my decimal? 2 places. The unit, seconds, coming up with my new unit. It'll be 1.2. 10 to the negative 2 is what unit, or what prefix? Sorry, you're right. Centi, seconds. It'll be 1.2. Centiseconds. Yeah. I might have picked that one just because I thought it sounded funny. How about the next one? We got our powers of 10 all the way down. How far did we shift? 2 places. What did I get? Did I start with a big number or a small number? Small number, so it needs to be negative. And I end up with 1.2 centiliters. That one's only two places, 1.2. Okay. Centiseconds, it's real. Last one, how far did we shift our decimal? 3 locations, 1, 2, 3. It's a small number. What do we end up with now? 1.2 milligrams. Okay. So a question was brought up. Do you have to go through and show the powers of 10 or your scientific notation in this? No, you don't. What we're showing here is how those prefixes are used, where they're coming about, how to manipulate them. Okay. How could I ask it on a test? I could say convert 0.0012 grams into centigrams. Okay. That is now an interesting question, because if I convert my 0.0012 grams across, it should go into milligrams. So how do I go into centigrams? Okay. It's going to be a question of doing a conversion, which is going to require a conversion factor, which we'll address in just a little bit. Okay. We can attempt to use other manipulations behind that. I would highly encourage you to not memorize what your math professor probably told you something about. Okay. King George sat on... King Henry died by drinking... yeah. King Henry, quite frankly, was not a very good person, which means memorizing anything about him is dumb. That is useful for understanding what you call each of the places in a number. Do not use that to shift decimals. The reason why, you won't do it consistently. Okay. And I know I was always consistent with it. You won't do it consistently. And I will tell you exactly when you will fail to do it consistently. On the exam, after answering 5 or 6 questions. Okay. So try to avoid using that King Henry nonsense. If you can do it consistently, you can come back at the end of the semester and be like, dude, I got an A and I used this, and I'll be fine. All good for you. Okay. But I highly discourage the use of that shifting decimal place with King Henry nonsense. Okay. Fractional notations. Okay, this is going to become important. In English, we could say there are 1,000 meters in 1 kilometer. Okay, we could have just as easily have said, what? There are 10 to the third meters in 1 kilometer. Okay, that works a little bit better for recognizing our powers of 10 and the relationships. What does that mean in mathematics? Well, our quick translation is that 1 kilometer equals 1 km equals 1,000 meters, or 10 to the third meters. Okay. What we want to be able to do is take that information and put it into something useful. And when you go through and solve any kind of question, how often do you see fractions? Rhymes with a lot. In fact, it kind of is a lot. Everything you're going to be doing this semester involves fractions. Do you see a fraction in any of that? No. So what you need to do is not only convert from your English into the mathematics, but then you also need to convert it into a fractional notation that is useful. Okay, well, how can I convert that into a fractional notation? Okay, well, 1 kilometer over 10 to the third meters. You might say, well, how is that a fractional notation? Well, what does that equal?
1.
Because I just said those are the same things, when I put one over the other, it equals 1. I can now multiply this fraction by anything I want, and mathematically it holds true. Because all I'm doing is multiplying by 1. Why would I do that? It allows me to play around with the units. Did I have to use this fraction?
No.
Okay, I could have just as easily written 10 to the third meters over 1 kilometer. Exact same thing. Why is the 10 to the third now on top?
Because you want it.
Nope. What did we say was the most important thing about everything we're going to be looking at? Obed shouted out the answer earlier. Units. Why is the 10 to the third on top?
So you can cancel out.
Because I put meters as a unit on top, and what shows up in front of meters in my conversion? 10 to the third. 10 to the third will always be tied to meters. Okay. The 1 unit, or the 1 value, will always be applied to my complex unit, or my prefixed unit. Okay. Could we do this with, say, centimeters? Yeah, why not? Okay. We can get 1 centimeter, 10 to the negative 2, that's a negative in there, meters. Perfectly valid. How many of you memorized that 1 centimeter is equal to 10 to the negative 2 meters? Nobody memorized that. Okay, fair enough. Did you memorize something else? What did you memorize?
100 centimeters in 1 meter.
You said 100 centimeters is 1 meter. Okay. Are those mathematically identical?
Yes.
Yes,
they are. What does the negative mean?
it's going to be small negative number. Well, possibly.
The negative means do that calculation in the other location. Where is the 10 to the 2 calculation being done currently? Where is it being done currently? Where am I pointing to? Okay, I'm pointing on the left-hand side. It's being done in the denominator. Okay. If I want to just say do that calculation, but in the opposite location, the negative just means do the opposite. How would I do that calculation in the opposite location? Well, if it's in the denominator, what should I do? What would now be in the denominator? 10 to the 2. There's what you memorized. This is dealing with what that negative symbol means. For those of you who don't like that, pretend I didn't say anything. Okay. Exactly. Okay. It's a mathematical manipulation simplifying potentially your calculation. I still highly recommend that you do not use this 100 centimeters, 1 meter. Your power of 10 should always show up in front of the core unit. Keep it there. Okay, that's our mathematical manipulation. We can ignore all that. We just talked about it. So here's to the exciting part. Okay, this is our next big leap forward in understanding within chemistry. So what I want you to go through and do is spend the next 5 minutes answering this question. And if you get it fast, that's fine. Just don't shout it out. Keep it to yourself. How many inches are in 3 feet? I don't know how isn't that doozy? How many inches are in 3 feet? Okay, you can share with the person next to you because it sounded like some of you got that right away. Everybody got that? What do you get? 36. Tell me how you did that.
3 times 12.
3 times 12 equals what? 36. That's not the answer.
Inches.
36 inches. Okay. I'll accept that. So 3 times 12 will equal 36 inches.
3 feet times 12 inches equals 36 inches.
3 feet times 12 inches equals 36 inches times feet. We still don't have a notation that makes sense, guys. Come on. Feet doesn't show up in the answer. It's supposed to be just 36 inch. How do we fix it? I need 12 inches over 1 foot. What happens to the unit of feet now?
Cancel out.
Now the units cancel out. 3 times 12 gets me my 36. The only unit left over, inches. Okay. And you may be saying, that was painfully obvious, Mike. Why are you telling me this? Because what happens if I change the unit to something you're not familiar with? You'll start just multiplying them. Well, if that didn't come up with an answer, you'll divide them. Well, that didn't come up with an answer, you'll add them. Well, that doesn't come up with an answer, you'll subtract them. Guess what will show up as your answer choices on the test? All 4 of those possible options. Okay? You need to know specifically when you should be multiplying or dividing. How do you decide when and how to mathematically use these terms? The units will dictate how your answer is supposed to be calculated. Okay. We're coming up with a method for this process. That method is sometimes referred to as dimensional analysis. Okay. Your textbook references it as 3 individual steps. For the rest of the semester, you should get sick and tired of me referencing these steps, because every time we do a conversion, guess what we're going to do? These exact steps. Step 1. What are we going to do? Write down our answer. What unit are we aiming for? Okay. We need to know where we are going before we can get started. What do we do next?
Given value.
Start down with what you're given. Okay. More importantly, not the number, but the unit. We will then attempt to insert what are known as unit factors. Those are our conversion factors. Where are we going to get those from? They're either your brain or they're the front of the exam. You are required to have certain conversion factors memorized. You need to be able to manipulate those within these equations. Okay? So, here's your first practice. What is the mass in grams of a 325 milligram aspirin tablet? Do you want me to work through this one, or do you think you guys can do it on your own? Think you can do it? Go ahead and do it. What do we want for an answer for the first one? Grams. Good. We want the unit. I don't care about what the answer is. And I'll still get people through this entire section up to the exam telling me what the answer is, because you can do that calculation in your head. Sweet for you. Your math in your head doesn't get graded. The work that you write down with the units does. If you write nothing down, you get no credit, period. That's the way it's going to work. Okay? You need to have a method. That's the important part in this. So, step 1, we want our final answer in units, grams. What do we start with? Milligrams. Thank you for that. You didn't say 325 milligrams, you said milligrams. We care about the unit. The numbers are irrelevant. A calculator can do numbers. Okay? Anybody can punch stuff into the calculator. Not everybody can punch it in the proper order. Is milligrams the same thing as grams?
No.
No, so I need a conversion factor. Okay. That conversion factor needs to do what? It needs to cancel out milligrams. Why do I want to cancel out milligrams? That's not my answer. What do I want to show up on top? Grams, because? Grams is in the final answer. Do I have a conversion factor between grams and milligrams?
Yes.
What is that conversion factor?
1 gram to 1,000 milligrams.
1,000 grams.
What does milli mean? Say that again. 1,000th. Okay. Power of 10. Milli means 10 to the negative 3. Our power of 10 always goes where? With the core unit. What is our core unit? Grams. What number shows up in front of our prefixed unit? 1. Okay. I now have my conversion factor. What happens with the units? They cancel, and I would have grams if I actually ran the calculation, so I can sub in my numbers. Everybody's back to me, so no one saw what happened. That was good. You guys didn't laugh, so I assumed you didn't see it. 325 times 10 to the minus 3 gets me to my answer. Some people used 1,000 milligrams as 1 gram. The issue I have with that is you're putting the power of 10 where? In front of milligrams. The power of 10, if you decide to use that, will then sometimes switch from being in front of the base unit to in front of the prefix unit. Okay? That's not a consistent method. The consistent method, power of 10, always in front of grams. Memorize what those prefixes mean as their powers of 10. You will always be correct. Okay. What is the mass in micrograms? How do we approach this one? In a 325 milligram aspirin tablet, what's our answer need to be? Micrograms. Our symbol for micro? Okay. That weird cursive italic looking M, believe it or not. What are we starting with? So we started off milligrams. Ideally, what do I want to get to? Do I have, and so those of you that are good with powers of 10 in your head, keep your mouth shut. Do we have a direct conversion between milli and micro? No. So that means I can't do that conversion. Well, what do I have a conversion to from milligrams? Grams. What does milli mean?
1,000.
1,000th. 10 to the negative 3. Where does our power of 10 go? I don't like that. With the core unit, which is our grams, 10 to the negative 3. 1 is our prefix. What unit am I in now? Grams. The milligrams cancel. Is grams equal to micrograms? No. What do I need to do? Another conversion. Ideally, I have this conversion. Do I have that conversion? Yes. Why are you saying yes? What do you know? What's that? What does micro mean? 10 to the negative 6. The power of 10 shows up where? In front of grams. I now have my conversion across. Okay? Yes? If you can cancel out the powers in your head ahead of time, you are welcome to do so. This level of question, because of this power of 10 canceling issue, typically shows up as a multiple choice, so you don't have to show any work for it. Okay? Where you will see questions pop up, okay, is when you have to show work because you can't internalize the calculation. For instance, see if I'm lucky. Oh, not quite lucky. Oh, that text is kind of small. Someone read that for me, starting in the upper left.
Nice take you have there. Mercy. Whoa, almost 5,000 inches long. It
Whoop.
didn't look that big.
Down, down, then down. Sorry.
Okay. Would you mind if I produced it under license? Oh, non. Here are the B blueprints. Hey, thanks, buddy. What? Almost 5,000 inches long. It didn't look that big. Inches? Non. It's in millimeters. Don't you have versions with imperial units? Imperial? Oh no, we don't. I see. Never mind. I didn't want it anyway.
What is this now referencing? We have our, what are known as our imperial or English units and metric. When we're converting between those systems, do we have just a simple shift of decimal place? No. In fact, it's not such a simple shift of decimal place that the entire American system has said, screw that, I don't even want to deal with it. I'm just going to keep my own system independent of that. Why? America. Oh no! That covered all my stuff. Okay, well, we'll have to fix that real quickly. This is what happens when you edit the slides real quickly before class. Is everything metric? No. Okay. So we don't have powers of 10 shifting things all the time. We're going to run into a bunch of other units popping up. So to convert between length measurements of English units of inches, notice that we don't convert into meters, we convert into centimeters. 1 inch is equal to 2.54 centimeters. Okay. If we look at pounds for mass, 1 pound is 454 grams. Okay. When we look at those conversion factors, how many sig figs show up in those conversion factors? This is a real cluster something. No, I can't say that. The last three, or the middle two, how many sig figs in those conversions? 3 sig figs. The 1 is an exact measurement. The 454, the 946 are significant digit measurements. So those only have 3 sig figs. If we take a look at the first one, 1 inch equals 2.54 centimeters. And we look at that and we'd say, how many sig figs in 2.54 centimeters? What does that look like to you? 3 sig figs. Until you do what? Till we read the footnote. The U.S. Bureau of Weights and Measurements has redefined 1 inch to be exactly 2.54 centimeters, which means how many sig figs in our 1 inch to 2.54 centimeters? It's now infinite. Why? Because it is an exact value. We have defined it to be that. Why have we not defined it to be that with all the other ones? Ego, probably. Probably a very large portion of it. Is that a question? Okay. So we have to be careful with those conversions. Okay, so here's our practice to go through on this one. We're going to be doing the exact same process we just went through and did. Okay? So if you have a method, you should be able to apply that method to an entirely new situation. If you don't have a method, you're pretty much SOL. The length of an American football field, including the end zones, is 120 yards. What is the length in centimeters? And actually, let's be a little bit careful here. The length of an American football field is measured to be 120 yards. What is the length in centimeters? Our basic setup, what do we start with? Unit of what? The unit that we're looking for in our answer. What's our answer need to be? What's the next step? What we started with, which was yards, 120 yards. We need to set up a conversion. Ideally, what happens? Yards, centimeters, and we'd have it. Do we have that conversion factor? No. So what does that mean we need to do? Convert yards to something else. I will leave that up to you. See what on popular demand, we'll go ahead and actually write down what the answer is now, because I think most people are there. And this is actually technically going to be wrong, but on a technicality, the calculation itself is correct. The answer comes out to be 10,968. You need decimals on that?
No.
Just 9,000?
Yeah.
10,968 centimeters. How many got that right? Whoa.
I got that.
What happened? Why did the rest of you get that calculation wrong?
It's 10,972.8.
68. 10,968. What? Why are all of you wrong? Well, maybe let's take a look at what Eddie did for us here. So what did you decide to do here? You said yards, and you wanted to convert those into what?
Meters.
meters. What is that conversion factor?
1. Yeah.
Yeah, sorry. And then what did you do?
Convert the meters into centimeters.
Okay. Centi meant 10 to the negative 2. That shows up in front of the core unit. I put it in the right spot? Yeah. And we end up with 10,968 centimeters. Is that what you all did?
No.
What did you guys do? You went yards to feet? Okay, so there were what, 3 feet in a yard?
Yeah.
Then what'd you do?
12 inches and 1 foot. And 2.454 centimeters.
You said, sorry, inches, centimeters, 2.54 centimeters and 1 inch. And you got what? 10,968, right?
972.8.
972. Oh, that's interesting. We did it Eddie's way, we got 10,968. We do it your way, we get 10,972. Let's not worry about the decimal. We'll realize again why. So what is wrong with this method? Why is this method not right? What do you got, Hunter? 2.54 centimeters into inches according to? It is defined as exact. So who's right? You're both right. How are there 2 different answers? There's our interesting question. Why are there 2 different answers that are potentially valid? Because this is going from English to metric, and the 2 systems don't always agree. So depending on which conversion factors you use, you start to introduce error into the conversion. This is why converting between English and metric turns into a nightmare, and potentially why the US just said screw it to France and walked away from that tank, even though they liked it. Because they realized to convert everything across into the pre-built English system is going to introduce error, and things are not going to function the same way. So a good question, how could I put this on the test? Okay. It's not a bad answer, except if I put it onto the test, which of those answers is correct? They are both wrong. The answer is actually 11,000 centimeters. Sig figs. How many sig figs are you allowed to carry through to your final answer? 2. 10,968 has 5. 10,972 has 5. 11,000 only has 2. You have to account for your sig figs appropriately. Yes. Sorry?
If you included the measured fee, wouldn't the significant figure one be wrong? The 11,000?
If you included the what?
The measured fee, like where it says is 120 yards. If that wasn't there, would it be the 10,000?
If I, oh, the measured.
Yeah.
As opposed to exact. That's actually why I added the measured. There is some confusion, ambiguity in the question as to whether it's exact or measured. So that's why I had to throw in the measured part. Okay. On a test, you should assume it's measured. Okay. The only way you should run under any other assumption is when it explicitly states it's exact. Okay. I added the measured here to make sure we have that extra measured device to help us realize it was measured. We excited about that? Yay! Watch your sig figs. You have to account for them. Okay. With that context, was either of those methods wrong at all? According to the error of our measurements, they both came to the exact same answer, 11,000 centimeters. Okay?
So that the 2.54 thing is standing out to me based on what we just discussed as far as conventions go. So what makes it right or wrong?
What makes it an error to say 2.54 or 2.54 and all the other fun stuff, as far as converting to centimeters?
It is a standard convention. A government entity came down and said, this is my answer. If you deviate from this answer, you are wrong.
It's a government conspiracy.
Kind of like the MLA. Are we good? Okay. So, because I'm still getting people fighting me on coming up with a method and using a conversion system. We can encounter a question like this. You've probably seen something like this in, say, I don't know, a math class. Harry wants to exchange his pennies for dollars. Harry has 100 pennies. Douglas is infatuated with silver things, and so will only exchange his dollar bills for silver objects. Okay? What does Harry have to do to get his pennies converted to dollar bills, and how many dollar bills can he get? Well, Harry has 100 pennies, Douglas has $3 bills, Sally has 30 dimes.
I was wondering where you were getting any of the black parts I didn't see.
So how do we have to process this? The way we should be processing this, and since you guys are actually kind of stumbling on this, that's awesome, because that means we need to come up with a way to solve. What does our answer need to be? I need dollar bills, and I'm coming from what? I'm coming from pennies. How many pennies do I have? Are pennies equal to dollars? No, so I need to come up with some kind of conversion factor to get from pennies to dollars. Within the context of the question, do I have that ability? No. Douglas will not accept pennies. So what do the pennies have to be exchanged for? Dimes. What is our conversion between pennies and dimes? 10 pennies is 1 dime. I can then convert dimes to dollar bills. 10 dimes, $1, and I now have my process set up. Okay? And if you've ever wondered in your math classes, why are they coming up with these stupid word problems? Okay? This is obvious. I don't need to set up something like this. I can just do it. Okay? Where it's coming from is effectively sciences when we throw a different question at you. Do you have any idea what a Snorlaxi is? Or what a Skittle fart is? Okay. Once the context has been ripped out from underneath you, how do you solve the question? You need a method to solve. That is dimensional analysis. Skittle fart was some random thing that came out of my brain. Maybe I was watching a Skittles commercial. I don't know. No. Right? So the method is what we need. Right? Stick to the method, you'll be fine all the way through. So compound units. Stupid thing keeps showing up. What is the speed, or what are the units for speed in your car? Miles per hour. Miles per hour. What is mph? It was a dumb question, admittedly. What does that mean? And what happens? We need to make this into a fraction, miles over hours. What do we have? We have the ability now to convert between miles and hour. A compound unit is really just a fancy way of saying another conversion factor. That's it. Okay. So if I have a motorcycle traveling at 105 kilometers per hour, what is the speed in meters per second? Okay. So we'll do the exact same thing we've been doing. What do we want for our answer? Meters over seconds. What did I start with? Kilometers over hours. Where's the 105 show up? In front of kilometers or in front of hours? The 105 shows up in front of kilometers. What shows up in front of hours? 1. Okay. Is kilometers per hour the same thing as meters per second? No? What do you need to do? What are you going to convert? I heard hours. We don't want hours in our final answer, so what has to happen in this next conversion step? Hours needs to show up on top, so the unit cancels. What do we want to show up on the bottom? What are we trying to get to?
Kilometers per hour? Miles per second. Wait, what? Oh, wait. Meters per second.
Hours is a measurement of what? Time. Kilometers is a measurement of what? Distance. If I'm going to convert hours, do I care about the distance? No. All I need to focus on is the time unit. Okay. What is the time unit I want to end with? Seconds. Okay. Hours, seconds. How many of you know the conversion factor between hours and seconds? Not quite. So I saw maybe 3 hands, so we don't know that one. So let's try again. Do we know a different conversion between hours and some other unit of time? Minutes. Why'd you pick minutes and not days? It's getting closer to the second unit. What is the conversion between hours and minutes? 1 hour. Come on, pen, work. 1 hour. Come on. 60 minutes. Is minutes equal to seconds? What has to happen to the minute? It must cancel by putting it on top so the unit can cancel. What shows up on the bottom? Seconds. Do I know a conversion factor between minutes and seconds? 1 minute is 60 seconds. What is my answer right now? Whoops. No. Stupid. So just so everybody's aware, you see what I'm working with? All that work has disappeared. So it's on the screen, but I can't see it.
Just do dots.
Yeah, many.
Hours. Cancels. Minutes cancel. Oh, I got that one pretty good. Oh, look at that. Minutes cancel. The unit I would now have would be kilometers per second. Is that what I want for my answer? No. What do I want? Meters per second. How do we convert?
Meters on top, kilometers on bottom.
What is my conversion between meters and kilometers? Kilo means 10 to the third. Where does my power of 10 show up? Next to my core unit, meters. What would my unit now be? Wow, that was the wrong one. My kilometers cancels. Kilometers cancel. And I would now have meters per second. I am getting some feedback, it sounds like, with you saying that this is too easy. Okay, so never mind. I lied about that feedback. Okay? So how far did the bike get in 120 seconds? See what you can come up with. And I'll give. What did we start with? How do we convert? Is centimeters cubed the same thing as inches cubed? So what do we need to do? We need to get rid of the centimeters and turn them into? Do we have a conversion between centimeters and inches? 2.54 centimeters is 1 inch. What do you mean that's wrong? That is exactly the conversion between 1 inch and centimeters. It's centimeters cubed that I'm trying to convert. Okay, so let's cube that. Whoops. So if we cube that, okay, well then it's just this, right? What is wrong with that? We have to cube the entire conversion factor. If you do not cube the entire conversion factor, you will get the wrong answer. Okay. So now the next fun test. Enter this into a calculator and tell me what the answer is. $498 divided by all that was 16. Yeah. I want the whole thing. Enter it into the calculator. I at least know you're doing it right because I can see your work. What'd you get for a number? Yeah. Oh, I was actually hoping to write that down. Oh, since you got it. The number you should get, or your calculator spits out, 33.898 inches cubed. Did everybody get that answer?
Yes.
Okay, well, if you seriously got that answer, then there's nothing for me to tell you. Most people screw that up, and I will bet that you screw that up. Okay? If you did not screw that up, then I'm not going to try and point out where you failed or where you could fail. If you did not get that answer, you need to talk to me because you will screw it up later on, okay? Or you'll screw it up again. Okay? Make sure that you can get that answer, or your calculator spits that out. Is that the correct answer? No, why not? Sig figs. How many sig figs can we report in our answer? And our answer becomes 30.4 or inches cubed. Okay? With that, we got to go ahead and stop.